Here's an example where it's important to make choices in the domain and range of an explicit solution of a first-order differential equation, and we're using the technique of separation of variables. This is from section 1-2, problem number 11, but I'm going to add an initial condition. So here's the differential equation. dy dt is t over t squared y plus y, and initial condition y of 3 is minus 1. We separate the variables, integrate both sides. We have y squared over 2 equals log of absolute value t squared plus 1 over 2 plus a constant. We gather the constants on the right hand side. T squared plus 1 is always positive, so the absolute value signs we can change to parentheses. And doubling both sides, we can look for the constant c by setting y equal to minus 1 and t equal to 3. So we find that c is equal to 1 minus the log of t. So y squared is 1 plus log of t squared plus 1 minus log of 10. And we bring the logarithms together and take the square root of both sides to find a formula for y. Notice how we have to choose y to be the negative of the square root of this quantity, because our value of y with the initial condition t equals 3 is negative 1. So you have to make a choice for the range of our solution. Now let's look at the domain of our solution. The quantity under the square root has to be not negative. So we say 1 plus this logarithm is greater than or equal to 0. So the logarithm has to be greater than or equal to minus 1. And if you exponentiate both sides, t squared plus 1 over 10 has to be greater than or equal to 1 over e, which means t squared plus 1 is greater than or equal to 10 over e. T squared is greater than or equal to 10 over e minus 1. And if you square root both sides, don't forget the absolute value. The absolute value of t is greater than or equal to square root of 10 over e minus 1. There's two possible choices for t. Either t is greater than or equal to that square root of that quantity, or t is less than or equal to the opposite of the square root of that quantity. But that square root of that quantity, that's about 1.637. So we're going to choose t to be greater than the positive square root, because that matches our initial condition. Again, t has to be greater than or equal to square root of 10 over e minus 1, because our initial condition was given at t equals 3. So now our second choice, now we've chosen the domain. We chose the range, negative square root, and now we chose the domain. T is greater than or equal to positive square root of this quantity. So now we have a solution function and the domain of the solution. This is not the domain of the function, but the domain of the solution, this one branch of the square root of the logarithm. And then we draw the picture on the right hand side, emphasizing the initial condition 3 and minus 1.